All right. Welcome everyone to this Edge of Things episode, the last one in 2021. And today we'll be discussing the IoT and Edge Developer Survey report. So with me is a very interesting panel of people who are knowledgeable about the industry. So we'll start with a little round of introductions because for me, they are well known. I work with them frequently, but maybe they are not known to you. So in the other on my screen, let's start with you, Rob.
Hey, everybody, Rob Tiffany. I'm a head of IoT strategy at Ericsson, and I've probably been doing IoT for too long.
That's one way to put it.
Yeah.
Welcome.
Yeah. Thanks.
Next is Kudzai.
Hello, everyone. Kutsai Mandi Teresa. I'm based out of Johannesburg, South Africa. I'm a technology communicator and founder of Industry 4.0.TV, which is a global media and education company around the topics such as IoT, edge computing, and currently involved in research in topics such as Industry 4.0. I also host an IoT podcast where I interview leading experts in this space. Some of whom are on this call today. It's great to be here.
Absolutely glad to have you. And yeah, if you have some time during the early days, catch up on the episodes of the podcast. It's really an interesting one.
It's good stuff.
Absolutely. Next is Robert.
Hello, Robert Andres. I'm Chief Strategy Officer at Eurotech, a company that for 30 years now is building the plumbing from a hardware or software side for the Internet of Things and distributed computing in typically rugged and demanding environments. And I'm gladly representing a company here that is a founding member of the IoT working group and a contributor to both Edge Native and IoT.
Absolutely glad to have you on board. And our last panelist is connecting right now to our platform, so is not on video yet. So I will give him in a few seconds the opportunity to introduce himself, but let me introduce myself. I'm Frédéric Desbiens, Program Manager for IoT and Edge Computing at the Eclipse Foundation. And my work is really to work with our community members and other people in the IoT and Edge ecosystem to drive adoption for our technologies, drive thought leadership, and overall try to figure out this whole IoT thing that we've been talking about. So it seems Angelo is still connecting, so hopefully he'll join us soon. But in any case, what you see with us on the screen right now is the cover page of our survey report. The survey is conducted annually by the Eclipse IoT and Edge Native working groups at the foundation, and the whole point is just to in our Eclipse perspective, and even with outsiders as much as possible, because we don't advertise the survey just to Eclipse members, but we try to go as far as we can go to our core constituency there. But the whole point is to gather insights about the state of the market, especially in an open source perspective, and to publish those findings in an open and transparent way, in the sense that the report itself is published under Creative Commons license, which means you can take it, and if you give credit to the Eclipse Foundation, you can reproduce the graphs, reproduce the findings, cite them, whatever you want. So please, if you are on this call, feel free to leverage this resource, which our community has been working on in the last, I think, since 2015. So that would be the 6th edition of the survey this year. So it's impressive. And fingers crossed on Angelo, but if for whatever reason we still have technical difficulties, we'll go straight away with our discussion of findings. And here he is, fashionably late, as all important people are.
Well, I mean, apologies for the delay, but actually there was some connection issue. So apologies for that. I hate to be late, but sometimes it happens and we have to deal with it.
Absolutely. And full disclosure, we are shopping for a new platform, so it's not necessarily your fault. So we were done nearly with the intro round, but if you want to introduce you to the audience, Angelo?
Yeah, I'll do that real quick. So Angelo Corsaro, I'm CTO for AD-Link, and very proud and active member of our Eclipse community.
Absolutely. And when he says that, he's involved in the Eclipse Zeno, Eclipse Cyclone DDS projects, as well as the FogOS Edge Computing platform. So, quite a busy man. Glad to have you. Excellent. So let's get on with our discussion of the findings. So let me focus for a time on the report. And obviously there I will be, skipping a few slides, but I cannot skip this one, the first one. Just a big thank you to the various organizations that supported the survey and amplified the survey through their social media channels. Really grateful for your support. Obviously, Red Hat, Eurotech, and Bosch, the three leader members of our IoT working groups, have been strongly involved there, but AD-Link with Angelo as well and others. So a big thank you for that, and special thanks to Kudzai, who was one of the media members of the media involved in spreading awareness of the survey as well. Okay, so we've got an executive summary and we'll explain how we run that, but you don't care about that. What you care are the findings. So let's start with this one. So we started the survey by asking our respondents, what kind of IoT projects they are working on. And this year, industrial automation, agriculture, and building automations were in the top three. So Robert, when you look at that, is this in line with what you're working on at Eurotech?
Yeah, I think the only surprising thing here, consistent also with last year, is agriculture being that strong. I think other than that, there is little surprises here. So obviously, there is other interesting pieces that come a bit more on the long tail, right? That is from environment to utilities to healthcare, and all of that is in the range of 15%, or automotive and home automation. It's all there, right? So it's a wide field still, and we see that this is all very narrow together. But in general, right, there's no serious surprises here, besides actually the strengths and the number of projects in agriculture.
Yeah, and this is just anecdotal, but I live in a rural part of Canada, and I've seen in the media, the regular media, reports about robots used to pick up broccoli, or a special machine that they built with lasers to zap the weeds in the field, which is obviously something that you would program. So at least I see that in my local community. So personally, I wasn't surprised to see agriculture that high in the list.
Yeah, I think we can say that we can certainly confirm that also for Eurotech. That's a very important aspect of vertical of our mobile ruggedized kind of hardware and the software solution, right? Is if it's potato machinery or any kind of fruits being brought out of the ground, or fertilizers in. It's actually that whole world of agriculture that is at the moment stepping up in terms of digitalization.
I just want to say that I applied Industry 4.0 industrial IoT technologies to agriculture all last summer. Actually, I was doing lots of projects in Eastern Washington on hops farms and in apple orchards. And so I could really relate to the agriculture. It was new for me.
All right. How about you, Kudzai? Obviously, you focus on industrial automation, given the name of your podcast. So, anything that you've seen there? And it seems that you are frozen. Oh gosh. Yes, waiting for him to reconnect.
So aggregate. I mean, I think you made an interesting observation. And the real question for me is if the growth that we see in industrial automation and agriculture, in fact, are both of those due to robotics. So maybe, this is something to reflect upon, because at least on our side, we have seen quite a bit of activity and growth in robotics overall. And so, I wonder, I don't know if we have that data, but if those increments are due indeed to new robotics applied to those domains.
I think you're right. And also, I've been obviously studying a lot. We talk about Industry 4.0. Believe it or not, there's an Agriculture 4.0 out there. And so you may have heard of precision agriculture. Farmers are trying to do more with less, right? We've had a lot of drought in parts of the world and fires and things, and so they need precision information, just like we use for industrial applications, right? And so monitoring, putting sensors out in farms and fields to tell us about soil moisture and nutrients. I think we're going to see that keep growing over time.
Yeah, literally, no pun intended there for sure. All right, excellent. So let's move forward now with our next key finding in the survey, which is about the top operating systems for constrained devices and gateways. And here we put together really the microcontrollers alongside with the IoT gateways specifically. And the next slide is really focused on the edge servers that you would find and whatever people are using in the cloud as well. So coming back to those constrained devices, we see obviously Linux and FreeRTOS as the main options for MCUs and IoT gateways respectively, with some market share for Windows, and Zephyr as a constantly growing option, at least in the open source perspective. So Angelo, is this in line with what you see or what you would like to see for the market?
Yeah, well, I think it's in line with what we see, and especially this year, we saw quite a few projects on embedded target adopting Zephyr. So, I mean, my expectation is that the growth will accelerate in the years to come because we see quite a bit of, especially on the microcontroller tied once again in some instances to robotics, Zephyr becoming a very popular operating system. And once again, we saw it, more than we used to be this year. So I would have expected a little bit stronger growth, but maybe, that's just the beginning of the wave.
And one question I had for you, obviously you work a lot with Rust, and Rust is making a greater and greater impact all the time on those constrained devices. But then typically people would do Rust on bare metal, so to speak, without necessarily a real-time OS or anything like that underneath. So what would be your preferred approach there?
Yeah, so this is what the Rust community would love to do, right? And what we would like to do. As you know, there are some interesting projects trying to accelerate that path toward being able to run, bare metal, Rust over bare metal. But I think we are not there yet. And even in our case, although we use Rust for probably 80%, almost close to 90% of what we do, there is still some 10% in which we would like to use Rust, but we are still, let's say, if I can use the expression, stuck with C. Okay.
Yes, indeed. You can.
So I know that I think that sounds familiar, right?
Yeah.
C in the end is a passepartout, and you can only do so much contortionism, right? And if using C is less contortion than using Rust on an embedded board, then we go for less contortionism. But so there are very promising developments on native and bare metal Rust. But as of today, on some target, we can actually, you can almost run Rust on Zephyr. We have done some experiments, but let's say that as of today, still, we are mostly running C on those targets. Okay,
that makes sense.
But
and
hopefully, 18 months, and we should be able. I think we should be able to have almost pair in terms of user experience and usability. So that will be interesting.
Yeah, and we have a question from the audience, and they are asking, what are the advantages of using Zephyr versus Linux?
Well, the point is that where you typically use Zephyr, Linux doesn't fit. So you can use Zephyr on a very small microcontroller. Zephyr, the other nice things of Zephyr is that essentially is a POSIX OS. So we have the same C software base that actually runs on Linux and runs on Zephyr. So we like personally we like Zephyr a lot, and the advantage is that you can run Zephyr on. Well, hold on.
He needs to bring in a prop.
This is not our board, and neither is Eurotech board. So we are neutral. Okay? But you can run Zephyr on this. That's a small STM32 board. Linux here, doesn't fit very well.
Yeah, absolutely. And even the BBC Micro can run it. And the other consideration I would say there is obviously using a small real-time OS versus a full fat OS like Linux is not necessarily the same use case and the same type of application. How about you, Rob? So what is your take on those operating systems, whether on constrained devices or even we can move on the edge servers and cloud if you prefer?
Yeah, well, I just echo what Angelo was saying. It depends on how constrained you're talking. Most constrained devices, don't run an operating system, or they might run, one of the real-time OSs out there. And so a real constrained device is probably not running Linux. It's certainly not running Windows. Like Windows IoT Core, it can only get down to Raspberry Pi size, I think. So, it just depends on what you think constrained is, I guess. And I agree, it'd be great to get Rust on bare metal. That sounds like a good future.
And this is something, to be completely transparent, that we start seeing happening in our larger ecosystem. The Drogue IoT project from Red Hat, for example, is trying to have a cloud platform in Rust with a device-oriented framework that does that. And even in the next few months, maybe we'll see Zeno support appear on that. Who knows? But in any case, that's certainly a trend that we see in action. Okay. In an edge perspective, we see Azure Sphere appear on edge servers, and obviously FreeBSD. That was the first year that we were asking about it in a cloud perspective. So to me, it was not so surprising to see it that high. But any insights about the edge server / cloud side of the pie?
Well, those can be very different things. Edge server makes sense that it's Linux or Windows. Azure Sphere is actually a microcontroller-based thing. If you're talking the real cloud, it's dominated by Linux, except for Azure is still based on Windows NT kernel, even though it runs Linux as guest hosts. And so, that's kind of where that is. It's all Windows server, but I'd say, at least on that cloud, Linux guest instances have surpassed Windows Server instances a few years ago.
Yeah, and that's a durable trend. I don't see that changing anytime soon.
Right, and I agree.
And again, what we see, if you want to put some kind of vertical perspective, I mean, we see typically more Windows, or we used to see more Windows in industrial automation, just because of historical reasons. Okay. But as soon as you move out of that, I mean, it's highly dominated by Linux.
That makes sense. Okay, going forward now with the next finding in our survey, and I'm glad you could rejoin Kudzai, since you literally froze at the very time I was asking the first question to you. So in this case, we are discussing on this slide the top edge computing workloads in our survey. And this year, for the first time, we were separating the workloads on gateways and servers to see if there was some variation. And the percentages changed a bit, but the order of the top 4 workloads at least was the same, whether we consider edge gateways or edge servers. So when you look at this, Kudzai, what do you think?
Okay, well, so for me, when I look at it from an industrial IoT perspective, most traditional automation systems use a simple architecture where you have a PLC connected to other devices over something like field bus, reading sensors, executing logic, and just driving actuators in a sort of like a repetitive fashion, right? And because those aren't really differentiating technologies, it's hard to gain a competitive advantage through the use of such technologies because they simply don't lead to a path of intelligence. So, but I think it's what we see there on the report is because organizations have since become aware that to gain that competitive advantage, actually there is a huge opportunity to gain a competitive advantage by taking advantage of the explosion in the compute capabilities with things like your GPUs, TPUs, and the likes. And so they're starting to get development teams to deploy smarter software at the edge in the form of AI. Hence the reason why I believe AI is the most common workload for both edge gateways and edge servers, as seen there on the survey. And also, I believe that again there is a shift in the culture as industrial organizations start to open up to the idea that having an edge device whose functionality is not only limited to executing some repetitive tasks, but rather to have them host software that could, like suggest actions on issues that could otherwise go unnoticed. So for me, I think it's really in line with what I believe is happening in the industrial space, particularly.
That makes sense. And Robert, you're the one who literally asked us to put this distinction between gateways and servers in the survey for this year. So were you surprised by the results? Any insights that you gathered from that?
No, actually, not really surprised about the results. What is interesting is the dimension that AI has in these numbers here, right? And I think it reflects where a lot of developers are at the moment focusing on, rather than what you see as volume deployments in the field yet, right? But it also shows, especially if you look at the gateway side, that the gateways become a lot more performant, right? And also, companies like us and at A-Link, we are all working on systems that have AI acceleration technology hardware in it that allow us to deploy a lot more efficiently these kind of workloads. So this is all coming together and is a big trend, confirmed here by those findings.
Yeah.
Yeah.
And we have someone in the audience asking, when we say AI here, it's for what purpose, whether it's vision, sound, sensor data. And the survey wasn't as granular as that, unfortunately. So we were shoveling all of AI use cases together for the purpose of that question. But typically for our panelists, what do you see the most in the field?
So actually, vision was in the survey, right? It just comes a little bit lower out than the sensor fusion thing.
Right.
So it was more granular. We only see here the top kind of ranking workloads.
Yeah. Well, what we see on the market, at least in our case, we see that vision is usually probably the most common workload. So I would say probably more than half of the time that's vision. For sound or ultrasound, I mean, we see some of that in, especially either in sound or ultrasound. So let's assume it's still sound, either in industrial, okay, or medical. And then, I mean, but I would say it's largely dominated by vision-related application. But I think I would like to put another spin on this data. From my perspective, you can read this exactly the other way around and say that it's not so much that people are focusing more on AI, but is that if you want to leverage AI, you need edge computing. Because you need to perform those computations necessarily much closer to where the data is being produced. Because especially with video, that's very large data that you can't send around easily, or is not very effective to do so. So I mean, from my perspective, the reason why it's so high in edge computing is because AI more than anything needs edge computing, and from my perspective, in a way, it's AI also that is accelerating, in a way, edge computing and some of the aspects related to edge computing.
That makes sense. All right, going forward now with the specific artifacts that people deploy for IoT solutions. And here, once again, we see containers at the top and then native binary script files. And serverless is something that we asked about for the first time this year in the survey. That's why we don't see results for that. So, Rob, you look at this, does it make sense?
Yeah, it makes sense. I think, especially if you go through time, obviously we've been doing edge computing and IoT for quite a while, and so it's baby steps, right? We used to push binaries down there, then we started doing virtualization to make that easier, and then obviously the rise of putting containers on devices. I mean, I think back as early as 2015 when I was at Microsoft, we were doing container-based stuff on our edge, open source edge stuff, and so that doesn't surprise me. A lot of players I know in the IoT space who kind of have giant core cloud platforms and do edge. They like you to be in the cloud, design all your analytics for your certain groups of devices, and then be able to push that down to edge containers and update them that way. And obviously, that's super important as we move into this world of mobile edge computing, where the edge might be in the cellular network or at a base station at the bottom of a cell tower. And so containers will probably be, in many cases, the only way you're going to see that happen. And so we're just finding new places to do compute, aren't we? But we need a uniform way to get pushed down those packages to those locations, no matter what they happen to be. So yeah, not surprising.
And personally, I was surprised to see serverless as high as it is as a first-year option in the survey. So is serverless at the edge really a thing, or
I'm not seeing it. I haven't seen it myself, but who knows?
Yeah, well, some people are doing it. For
somebody
sure.
is. Yeah.
Indeed. In any case, it will be an interesting trend to see over the years as we will maintain that particular option in the choices.
Yeah.
Okay. So what's your take on all of this, Angelo? I know that FogOS supports straight binaries, virtual machines, containers, and even more. Given it's pluggable for that, but
yeah. So essentially, our stance on this has always been that as the edge is characterized by heterogeneity, right? All kinds of heterogeneity. Just marrying your platform to just one way of bundling up your one element of your application was constraining. And so, I mean, this is, I think, this is compatible with what we see. It's compatible with what we thought, we needed to support going forward. And again, we continue to believe that when you go in the cloud to things continuum, your overall application will necessarily, in the cloud, you want to use container or VM, right? But if you want to deploy down to a microcontroller, as we do, even a container is too big. And so in that respect, obviously, we deal with binaries. But what we are starting to look at, and what will be interesting going forward, is what and if WASM will ever roll in this world.
Okay, so in other words, is WebAssembly at the edge the next hot thing?
Yeah, exactly.
Yeah, I'm actually seeing that. Our friends over at Losant, they just launched a WebAssembly thing for their edge gateways. Yeah.
And so we are seeing that warming up. So, yeah.
So people are trying that server-side WebAssembly at the edge, but will that work in your opinion, Angelo?
I think absolutely. I mean, right now it's a question of, we've been looking at it quite closely, and for certain things, I think you can use it right now. For certain of the things that we want to do, there still need a little bit more work on the ecosystem, but I think it has the potential to be quite disruptive.
Yeah, that makes sense. Overall, this is a fairly new thing, so the ecosystem of tools and even platforms to orchestrate all of that is not necessarily there yet, but maturing fast for sure.
Yeah.
All right, going forward now with our next finding, which is around the top concerns for IoT and edge computing developers. And you see the top 5 for this year on the slides. So when you look at this, Robert, it seems we have the same top 5 as last year. Any observations on those concerns?
I think this perfectly reflects where also our customers see the major challenges that they are facing. And security being extremely high on that list makes perfect sense, right? So if you are in an industrial environment, especially if you're in utilities and energy, in critical infrastructure, companies need to find a way to get a properly, let's say, certified secure edge. And this is one area where we have investing a lot in actually getting the commercial version of Cura, even IEC 62443 and PSA level 2 certified. So that's an aspect that cannot be overlooked, right? It's before you deploy in these kind of environments, you need to have a security story. And given all the other answers that we saw in the survey on the security side, it clearly states we are not there yet, right? So there is a lot to be done, and we as a community also have to help solving that particular issue, right? I think we made major steps in the last years, right? And maybe to connectivity and deployment, just to look at the first 3. Connectivity, if I remember right, the question was not connectivity just on a networking perspective. It was really connecting the assets in the field to the edge to the cloud, getting all these kind of things working together. It seems to be still an interesting issue. And deployment, I can only put up one important aspect that we've been seeing a lot: to onboard just that part of deployment, right? To onboard a larger number of assets on any of the large cloud platforms is still heavy work to do. A lot of manual involvement, right? So we're all working on zero touch kind of onboarding, secure onboarding mechanisms that get that worry away. So I think it's very consistent what we see in the market.
All right. And when you look at this, Kudzai, how do you react?
Yeah, I guess for me, I really agree with what Robert said there. So this one is not really surprising to me, because as far as I'm concerned, or from the people that I've been talking to, security remains one of the biggest, or lack thereof, remains one of the biggest barriers of adoption to IoT. So I guess that concern is trickling down from the top to the developers, and security is a complex topic, because you have to secure data at rest. You've got to secure it when it is in motion, and there's also the management of the security infrastructure itself. So for me, I get where the concern is coming from, and also when it comes to connectivity, I think that's something also that developers will certainly be concerned about, because it's not only a matter of what size bandwidth you need or what connectivity options are available to the device, but there's also things like what amount of power is available to connect and things like that. So yeah, for me, it's something that confirms what I've been hearing and seeing on the ground.
And when we look at our surveys from the past, security has consistently came up the top as the #1 concern. So Kudzai, why is it so hard to get security right? Because if we were getting it right, it would be less of a concern for developers, right? So why is it so difficult to get it right in an IoT and edge perspective?
I guess to a certain extent, it's mainly because there is no standardized approach to securing IoT infrastructure, I guess, and most organizations are actually left to fend for themselves, to actually come up with a strategy. I guess if they could be a standardized approach that companies could follow, I think that would help avert the problem of security.
I might just a little bit contradict that. I think we see standards evolving. It's just that they're so tough to meet them because it is typically a hardware-software combined story that you need to certify. And that is a challenge for all these organizations out there.
So the complexity and the number of moving parts in the solution overall is the main problem there?
So I think especially the industrial, the more demanding kind of customers require is a security certification that can be inherited in higher level security certifications as well for the whole system, right? System integrators need that in order to prove that what they've done is right to their customers from a security perspective. So standards like ARM's PSA, right, or the IEC 62443, which is probably the 27001 equivalent in OT, that is now getting traction in nearly every vertical segment, are sort of the bars that we have to meet. And it is challenging, right? But there is more and more companies following that path. And again, we very proudly got our first devices certified on that level. But it's all very new and it's very challenging, right? It does require a massive investment and dedication, and it requires hardware and software to come together in a smart way, right? You're talking TPMs integrated and lots of other elements. Now, the interesting thing is, even if you look at the survey, right, you see the different technologies that we ask for, how many of those have been adopted in what way. You can see on a software level that, for example, certificate-based security mechanisms, X509-based, you see a lot more and being more adopted than secure boot, than a TPM. But you need to bring all these things together. Device attestation. You have to do this very early in the supply chain already. These are all things that are tough to do, but are a requirement together, right? But the standards, I think we see evolving and being there. They're just hard to meet.
And we have a question from Clark in the audience asking what your respective organizations, dear panelists, are doing specifically to address the concerns that we saw in the top 5, for example. So any specific initiative or idea that you are driving in the market to address those concerns?
Yeah. I've worked on a secure IoT system over the course of this last year because I agree security is the biggest headwind that we're all facing. It's holding back the entire mega trend. Obviously, security can hold back everything, right? All progress yes. We're trying to make, digital transformation. It can blow up Industry 4.0, right? We all assume it's going to happen, but you shouldn't assume. Security can kill all of it. But what I've learned over the years in IoT, security, obviously security is hard, hardware is hard. A lot of times in security, we're so accustomed to having human on the other side of the device to interact with maybe a device management system, right? But when you have a device down there that's headless and it doesn't have someone to interact with it, it absolutely makes it harder. I've also seen the giant, obviously I've been with the biggest IoT players in the world, and I've seen different approaches. I've seen going really hard with X509 and seeing very little adoption of that platform because it's too hard. And I see others go with like some kind of, security token type thing, and they have better adoption because it's easier. And I think we all know that there's that balance between ease and hardness and secure and not secure. And so far, going with the easier path is winning. But of course, that's also why we have giant botnets like Mirai and other things who are taking over these devices. So it's a tug of war and it's a struggle. It's a journey. We're all going to be on this journey forever, aren't we? And so I know there's lots of standards. We tell people you need to have TPM chips. You need to follow all these things. Whether or not people are going to listen is a totally different story.
Absolutely, and we have a comment from the audience from Kate, one of the leading figures on the Zephyr Artos, who is mentioning software bill of materials to make things transparent are a useful tool in that, and certainly that's an approach that we've driven a lot at the Eclipse Foundation specifically. We recently got some kind of certification around that from ISO that I don't remember the number about. But in any case, we're taking this seriously, and the Linux Foundation is getting this seriously, especially around Zephyr and the Linux kernel. So things are certainly headed in the right direction, but there are so many things to take into account that we won't unfortunately solve that anytime soon. But doesn't mean that we shouldn't try, for sure. In the interest of time now, getting forward with our next key finding and switching gears a bit, since now we'll be focusing on programming languages. So from the respondents on our survey, it seems that C is still the number one programming language for constrained devices. And on the other hand, Python climbed up the ranks to be the number one choice on gateways, edge servers, or even in the cloud. So looking at this, Angelo, I know you are a big Rust fan, and Rust was mentioned, but at a lower ranking. Any reaction to that?
No, I think so. Maybe I will give my perspective on this. So C as number one on constrained device, yes. Yeah, so no doubt about it right now. Rust is growing, but again, if we look at very small embedded devices, C still is the way to go. Then if we look at Python as the language of choice for IoT and edge gateways, as well as edge server, I mean, I would just be careful in making sure that people understand what that means. So at least I will give my interpretation. That is for application developers, because for infrastructural software, okay, usually, you still use some other languages. And it's for the infrastructural software that typically you have on those gateways and server that we see Rust growing, and for which also we have embraced the Rust. So what I mean is that Python, and maybe next year we should make a clear distinction between, is it a language that they're using for developing applications or infrastructures? And the popularity of Python, comes mostly also from, and perhaps is related also to the fact that many of the computer vision framework, they provide Python API that then obviously behind use native library, but that's usually how, data scientists would use those. So again, I would make this very clear separation, because when we get into edge gateways or edge server, there will be some element of infrastructural software that for sure is not written in Python. And I think maybe next survey will be good to try to look at those. To give an example, right? If we have a Xeno router deployed on an edge gateway, the Xeno router is written in Rust. But if you have application deployed alongside, those might be written in Python, right? In JavaScript. That doesn't really matter. So I think that distinction might be important at some point. But otherwise, with this disclaimer, I don't see any surprise.
How about you, Rob? When you look at this, any specific reaction?
Yeah, C is not a surprise on constrained device. I would never see Java on a constrained device because it doesn't fit. When I see Python, it tells me that it's just because it's easy to use and lots of developers know how to do it. Obviously, Python somehow is the number one language in the world now, and it's because it's easy. But that's great to have an easy language because you can do data science with it. But it's not what I'm seeing at all. For cloud stuff, it's all about performance. Go is taking over the world. It's not even close. Now, obviously, it's coming from behind, right? Just like Rust. We're at the very dawn of Rust. So it's got a long way to go, right? It can grow at a high rate, but it's going to take a while to get in good percentages, right? If you look at most of the open source technology being built today, Golang, just because it's got high performance like C, but it's easy to use. Once .NET went to .NET Core and cross-platform, it probably is in second place or third place with Rust and Go for high performance. And so that's the kind of stuff I'm seeing, because at the edge cloud and cloud, it's all about high performance stuff. Python's great once you're applying analytics, right? But as far as extreme scale and performance for millions of devices, that's kind of where I'm seeing things.
Yeah, that makes sense. And Go was mentioned, obviously, not in the top 4 that we put on the slide, but certainly that's something I saw when I was at Pivotal too. When we had so much Ruby code and Go code in everywhere that we were doing. Yeah.
yeah. And it just tells you, well, I used it because it was easy for me to do. It doesn't mean it was the best thing for the customer, though, right?
Yes, exactly. Right? I think that's a good tagline for Ruby. Exactly. All right, going forward
I'm gonna create Twitter in Ruby and see how long that lasts.
No, but don't joke. The first version of Twitter was written in Python.
Oof.
Yes, I think that you're right, and they had to rewrite everything.
They had to rewrite it.
and it's a bit like what you did with Zeno. It was OCaml, and now it's Rust.
Yeah, but OCaml, honestly, is a great language, and it has much better performance than Ruby or Python. If you write proper OCaml, you get close to C.
That's true. Okay,
but yes, we were proud OCaml user.
Key finding 7, now switching from programming languages to protocols. And this year, MQTT is both the top protocol, so to speak, and the top IoT-specific protocol that we have. It seems we have a significant decrease in the use of HTTP and REST, in IoT, at least in the respondents for the survey. So let me make that bigger. And then MQTT, and plain REST, TCP/IP, and Sparkplug, which runs on the top of MQTT, is new to the survey this year. We introduced it this year and sees, no, we introduced it for the first time last year, sorry. But in any case, a steady growth for Sparkplug at 8%. So looking at the world of industrial automation, Kudzai, obviously OPC UA is a big thing in industrial automation. It's not that high in our survey, but apart from that, any big discrepancy or any big observation about this? And it seems, sorry. We didn't have sound for a while.
Okay. Yeah. So, well, if there's anything that I'm not surprised about all on this survey, I think that's the fact that MQTT is the most popular IoT communication protocol. I first started writing about the potential of MQTT to become the de facto IoT communication protocol about eight years ago, and back then there was very little was known about MQTT, but what really convinced me that this could become something big was this simplicity, and I believe that's exactly what has propelled MQTT to become the most preferred IoT communication protocol today. So I'm not surprised that developers prefer MQTT over many other protocols, mainly because of its simplicity. But of course, there are many other features that make MQTT stand out. But I guess as far as industrial IoT is concerned, the power of MQTT, for lack of a better word, it lies in being underestimated, because at surface level, it just doesn't seem like a communication mechanism that could be used reliable in industrial facilities, but it just continues to deliver, because it's simple, open, lightweight, fast, developers love it, so that's why it continues to grow. In fact, the whole idea of moving from a tightly coupled request-response pattern of communication to a more decoupled event-driven communication pattern makes it such a compelling choice. And also, as a consequence, I'm not surprised at all that Sparkplug is also growing steadily as a standard definition of topics and payloads over that MQTT network. And then as for HTTP, well, it continues to be useful in some instances, but I guess it might be living on borrowed time when it comes to IoT communication protocols.
That makes sense. And
so if I may, I mean, this number is interesting, right? And I think there is an interesting observation. So MQTT, well, I think 3% growth, fine. I think it's stagnating now, right? But what is interesting, and why do I say that? Because if you look at the rest, from 2020 to 2021, there is a drop of right about 50%. And the drop of adoption of HTTPS, REST, and TCP/IP didn't go to MQTT. That's why I say MQTT is stagnating. And I think we will see soon some interesting new entrants, because that's what the data is showing, right? So I do agree for IoT. So device to cloud MQTT was a good solution. It falls short for Edge. And I think that's where we'll see innovations and where we have some pretty innovative, open source project in Eclipse. And for me, what is very interesting is the fact that we have, if you make the sum, you're missing 50% roughly, right? That's going some other place. And that's where we'll see the new entrants in the year to come.
Yeah, although all on that slide, not it doesn't have 200% since people could pick multiple options.
Of course, but still, right? Yeah.
Yeah, absolutely. And a new option we had on the survey was Zeno this year that you are working on with, I think, 6 or 7% of people saying that they are leveraging this. So for a new option, it's certainly
which is a 1-year-old project, by the way. So yeah. So, but anyway, so I think
so there's place for growth in the market and consolidation of the leaders at the same time.
I think it's important to note, right, that what is reflected here is just that MQTT is a very universal, very reliable protocol, right, for its simplicity. It is designed for telemetry data first, right? So is it going to be the choice for every kind of data to be transmitted, right? Probably not. But for what it does, it has been extremely resilient, right? And it was designed at the very beginning. And Eurotech is a part of that story. So Eurotech was co-authoring MQTT back then when IBM did work on these oil and gas projects, right, that led to MQTT, is to run all this in an enterprise service bus fashion over satellite links that are not very reliable. And that today still gives us an amazing resiliency for a lot of different kind of communication patterns for telemetry data. Right, but to the point of what Angela said is, there is going to be different patterns of traffic that afford different things. But for what it was designed for, I think it proves still to be the best out there.
All right.
And I know that the telecom guys are still waiting for lightweight M2M over CoAP over UDP to get traction. They're still waiting.
Well, that's the thing, because it tries to address interesting concerns like firmware updates and monitoring in one convenient package, but for whatever reason, it doesn't get traction. So why is that, Rob?
I don't know. It's just no traction. And actually, this is a developer survey of preferences. When I look at broader surveys globally, HTTP, REST, TCP/IP is still way ahead. MQTT is still in second place. Remember, some of this is just familiarity, ease of use, stuff that people know. There's nothing more ubiquitous in the world than the web, right? And so it's something people know innately, right? MQTT is something they would have to learn. And it's obviously, we're all very familiar with MQTT. But all kinds of people are out there doing IoT, right?
Yeah, and obviously they don't operate over battery power, because
That's
using TCP and HTTP over on battery would be suicidal. You change the batteries every 2 weeks, given the size of the headers and all of that.
Yeah, you're right. You're right.
So there are sub niches there that we should dig into, but that's the problem with this survey. We try to keep it easy enough to fill in 12 minutes or so, which means we cannot ask the very, very granular questions that we would like to ask to all of those people.
But to your point, an earlier slide, we saw that somehow agriculture was number 2, and agriculture means an outdoor device on battery life, and people are going to have to start taking that seriously.
Absolutely.
Yeah, exactly. You don't do REST in a field in the middle of nowhere.
But that's what people will try first, because they know
and fail. Right?
And fail. Yes, I think you are correct on that front. All right. In the interest of time, moving forward now with our most used connectivity technologies, and here, plain Ethernet, Wi-Fi, all of the usual suspects really are there, with cellular playing a role. And here we put together 4G, 5G, because apart from a few fringe benefits, using LTE versus 5G doesn't, for the time being, bring a whole world of differences. At least
you're killing me.
Yeah, well, we could. We could argue about that, right?
Yeah,
Right.
let's
At least
stab the Ericsson
in
guy.
my corner of the world with the services I get, they probably don't use your excellent gear then for whatever reason. Rob. Now, when we look at this, any surprise in there? We had a number of options like Zigbee and all of the usual narrowband options coming lower than the big four that we see here. So there's usage for Zigbee and Dash 7 and LoRaWAN and all of that, but in the 15% range. So any surprise about those leaders there? Looking at that, Rob.
Ethernet is all over factories, so that's not a surprise. Wi-Fi. This goes back to why people are using REST. It's there and it's familiar, right? And so Wi-Fi is there, so developers use it. Cellular is popular when it's outside and moving around, right? A truck, a car, right? Why is 5G going to be important as it gets rolled out? Way 1,000x more capacity in the system. All these smart city projects we want to do. Really quickly with 5G, you can have 1 million concurrently connected devices per cell tower. So that's why 5G is going to be helpful for these giant scale IoT projects. But that's still in the future. The last thing I would say is, especially in agriculture or places where there's no coverage, I'm seeing LoRaWAN get a lot of traction.
Yeah, and that makes sense. Now, specifically on the question of 5G, there's been a slew of announcements recently where some cloud hyperscalers, I won't name, come to you and say they will deploy 5G networks in your factories or whatever on your campus. Do you see that as a growing trend?
We are already seeing all of the major giant manufacturers, and you know all their names. They're already kicking the tires and trying out private 5G in their factories to see if they can replace Ethernet or Wi-Fi. So it's early days, but they're checking it out.
Yeah, but again, I mean, this is honestly what, well, we've been, even before 5G, we were having offering on 4G precisely for the reason that Wi-Fi, especially if you have moving things, it doesn't work very well, okay? And in a factory, sometimes you have moving things, lots of electromagnetic noise. So, and 5G is, I have to agree. I mean, it gives you far more than 4G, also for in terms of QoS and real-time application that you might want to do in some industrial settings. So for us, the real power of 5G is actually in private deployment.
Okay, interesting.
Yeah.
That's something that we should dig on in the next edition. Yeah,
and if you want some other highlight, what we are seeing, okay, that's early, but we'll see where it gets. But again, we spoke quite a bit about Zephyr and embedded devices. So in some robotic application, very constrained robotic application, and there, by the way, there are standards coming up for this. What we are seeing is open thread. Okay, so the world is becoming more and more heterogeneous, but there is a market that will be, quite significant. Okay, that is standardizing over open thread. And for instance, we have now, because of that, we have now even then working open thread over Zephyr, right? But this is another area that we see growing, and we see, it was rare that we would see in the past. But this year, it came on our radar quite consistently. Yeah. So it's not there, but yeah.
And to me, the fact that Ethernet is at the top wasn't surprising, in the sense that power over Ethernet is a big enabler for some types of applications in factories or digital buildings where a single cable literally can deliver everything. Do you see that as one of the reasons as well?
For Ethernet?
Yeah, for the fact that power over Ethernet exists as a standard.
I think the other reason why Ethernet will remain dominant in industrial automation, because even if you transition toward, EtherCAT is Ethernet based, right? TSN, it's Ethernet based. So the place in which it is, it will remain and perhaps even grow a little bit because of erosion with respect to some of the industrial network that used to be called field buses. Okay.
All right. That makes sense. It seems we are at time. So, panelists, do you still have a few more minutes so that we at least cover what we had planned for the broadcast?
Sure.
Yeah, sure.
Okay. So let's continue then. And if some in the audience need to drop, our apologies for starting a bit late and having little technical difficulties at the start. All right. So key finding 9 was on security-related technologies, and specifically the top 3 was communication security, and specifically TLS, DTLS, and things like that as first, data encryption, and analytics anomaly detection as the third ranked option. So Robert, specifically, you asked us once again to add analytics, anomaly detection, but any surprise in the top 3 there?
No. Again, I have to repeat myself. Not really a lot of surprises. I think the interesting thing here is to read what is used, right? What is most often used, and the most easy kind of implementation of security elements is securing the communication, right? We all do that now, right? Also, data encryption in REST. Analytics, I think that's the interesting one that we see coming up more and more, where you try to capture with anomaly detection things that are very difficult on the OT side because of existing infrastructure that cannot be, extended with modern security technology easily. That becomes a very important aspect of any overall security strategy and architecture. So we see that coming more and more. We unfortunately didn't have a question here to ask how much of that is done where, right? So we see an increase of doing this kind of analytics, even getting out to the edge, right? Where you look already on a gateway level on specific data and watch out for anomalies. So I think that is an interesting one that confirms something that we've seen. In general, the more fascinating part comes actually more on the long tail, right? Is other security technologies that are harder to implement, like certificate-based stuff with TPMs and so on and so forth. They are there, but you see that adoption is still relatively low because it's hard, right? And it's our responsibility to make it less hard to adopt it.
That makes sense. And Kudzai, security, as we discussed earlier, is important in industrial automation, and we see the top 3 there. But are there things that are not mentioned on the slide that people working on industrial automation should think about when they think about security?
Oh, well, no, not really. But yeah, I think I'll like to agree with what Robert has already highlighted there, to say really IoT remains the simplest way really of securing the IoT, the movement of data between one system to the other. It remains with securing the communication itself, using the things like your TLS, and the certificate-based security is a bit complex, and I don't see much of it happening in the industrial space. Perhaps again, it goes to the issue of having standards and not like having people follow those standards in executing their security strategies.
Now, one thing that I often heard mentioned in our community meetings for the IoT and Edge community at Eclipse was that putting devices in quarantine could be a way when they are compromised to manage things, in the sense that maybe the network detects that a device is compromised, or maybe that devices do automated checks on themselves to see if they have been compromised. But do you see any of that happening around the industrial automation, or is this a trend that's confined, let's say, to public transportation or devices you put in the field?
Well, no, not. I don't see that happening as yet, because I mean, one of the things about securing the industrial automation communication network has always been about seclusion. Like keeping that separate from the IT networks. But now it's getting harder and harder to actually achieve that, because now you also want the goodness of being connected to the cloud and other networks. So I guess some other methods have got to be found to make sure that you secure an industrial communication network.
Okay, that makes sense. All right. Finding 10 and 11 are about the dominant CPU architectures. So finding this is about constrained devices, and we see all flavors of ARM really dominating the field, with RISC-V mounting slowly a challenge there. And in 11, we see that on gateways, ARM is quite strong as well. And with obviously Intel or the x86 architecture, I should say, there are AMD choices there as well, putting a quite good fight. So overall, are we in an ARM world for forever, or will RISC-V mount a more serious challenge in the upcoming years? So Rob, what's your take on that?
Well, clearly we're in an ARM world on devices, on edge gateways. We're in an ARM x86 world, and RISC-V is going to mount the same challenge that Rust is mounting. And so stay tuned.
Yeah.
But
Okay,
besides,
so you see definitely it happening. So are you already leveraging that in some of your more exotic 5G gear or something?
No,
at this point?
I'm not
yet?
very exotic. Nah.
No, but I think the interesting news is that if you look at what has happened in the ARM ecosystem, is especially on the server side, Rust, you now compare ARM. It bugged me. So ARM, was historically weaker than in terms of market adoption of x86. So it's interesting already the result of this survey. And if you think that now with Ampere and the 80-core processor from ARM, I mean, it's going to be interesting, the result starting from next year, right? But I think that ARM will now, has the potential for completely dominating even the edge server market.
Yeah, that makes sense, and especially now that you can even have ARM cloud options as well from a variety of suppliers. So certainly one big argument you were making at E-Link is that now you can have those kind of ARM-based workstations where you don't need to cross-compile anymore, right? You can do ARM all the way from the very beginning.
Yeah.
I think the tricky thing will be the various feature set among all of those implementations, and in the sense that going from one chip to another, yes, it's ARM, but you don't necessarily have the same features implemented on the silicon. So do we see some kind of fragmentation being a kind of issue that developers will need to tackle, or will the tool chains take magically care of that?
Magic. Tool
Magic?
chains will be magic. Yes. My big takeaway is, after watching the last Apple event, their M1 Max Extreme processors are so much faster than anything else on the planet that everybody's going to say, I want those Apple ARM chips on everything. Because it's like an order. It's just so much faster than anything else we've ever seen. And I'm sure people are going to be asking Apple I want your chips.
Okay, given that, do we see the Mac returning as an actual gaming platform or something?
Maybe.
Who knows?
Maybe.
Who knows?
Yeah.
Because that's my problem, really, in refreshing my current personal machine. Those Macs are really attractive because of the power of the chip. The one thing that would refrain me is that it's not a good gaming platform, and I bought a gamer and a coder. So what do I do if I have a single machine on my desk?
Stop playing game and use a Mac.
Yeah. Yeah. Oh, yeah. But you know what? To your point, we've seen PlayStation and Xbox players use different CPU architectures over the year. They've used PowerPC and x86 and ARM, and so who knows? The next generation PlayStation or Xbox may adopt a high-powered ARM chip like you're getting from Apple. Who knows?
Yeah, that could happen for sure. All right, and then key finding 12 was the last one we were planning to cover, at least in the length of this broadcast. So let's go with it. So in this case, we were focusing on completely different thing, which is the type of data that people store in their databases. And time series, highly popular in historian databases, came really, really on the top, with log data and device information as the two authors. So, Kudzai, when you look at this, why are time series data the number one choice there? Any reason for that?
Yeah, I think it's mainly because I mean it's been proven time and time again that the data needs to be stored in a way that reflects the sequential order of events. Even the analytics platform themselves, they work best when they're actually being fed such kind of data. So this isn't a capability that is inherently backed into the some common relational and NoSQL databases. So I guess that's the reason why we're seeing more and more rise of the time series database as a choice for storing data, so that at least they can be compatible with a lot of analytics systems.
All right, and Angelo, when you look at that and the way that people are storing data, any insights on that?
Yeah, so I think it's pretty much consistent with what we see. So for, sensor data, usually that's what most of the time we do. And by the way, I believe, even if we do a very simple statistics, right? The most used backend connector for Zeno is a time series database. And the second one is a key value. And the third one is the file system. Okay, so that's our own statistics. Yeah. So I think it's consistent, and it just reflects the kind of data that are dealt with in these applications, right?
That makes sense. It's about capturing what's in the real world and then doing something with it. So the something being, well, you want to be as flexible with it as you can, so you store everything and then you figure out and in your data pipelines what the data means. I think it makes sense. Okay, so well, you've been already very, very generous with your time, dear panelists. Thank you very much. There's much more to the survey itself. There are quite a few findings we didn't cover. And obviously, I've got a feeling we could talk about this for hours and hours with this lineup. Thank you so much for sharing with us your insights. And hopefully, we'll have another opportunity to go even deeper on some of the topics we broached today. So, Robert, Angelo, Kudzai, thank you very much for spending some time with us today. Happy holidays, Merry Christmas, Happy Hanukkah, even for those who celebrate that and we missed it by a few days. In any case, thank you so much. And for those of you who didn't in the audience look at the survey report, you can download it using the action button at the bottom of the screen. So please feel free to do so. As a reminder, the report is published under Creative Commons, so you can cite that and reuse the visuals in anything that you'd like, as long as you give credit to the Eclipse Foundation. So before we close the broadcast, any last word from any of our panelists?
I'm glad that we do this, year by year. This survey and also the adoption survey. I think it's one of the most earnest kind of reports you can get and reuse down to the demographics and everything else. So we certainly always appreciate and look very much forward to get that data and work on even better questions next time.
Yeah, indeed. Any other words of wisdom?
Oh yeah, sure. I think this has been very valuable, even for myself as a content creator, to know exactly what people are interested in. So at least that will help me focus on what to deliver to the audience. So yeah, thank you so much for that.
Excellent. So once again, thank you to our panelists. Thank you to you in the audience for joining us today. And stay tuned. We will reveal in the next few weeks information about the 2022 episodes in this Edge of Things series. If you have proposals for topics, if you have requests to us to put in the program, now is the time, because we are busy planning the next season. So let us know what you think. And once again, to our panelists, a big thank you and happy holidays.
Yeah, thank you. Bye-bye.
Thank you.
Thanks, everybody.
Bye.